The information presented is for informational purposes only. The opinions expressed are not necessarily the opinions of any Daikin company. This information should not be confused for accounting, legal, medical, or other professional advice. Please seek advice from a qualified professional for any specific questions.
It's actually a very safe refrigerant. Daikin wants to be involved in the community.
Making another touch point to build my brand.
So the first question we ask everyone is, welcome to the Accelerated HVAC Success program. My name is Ben Middleton. I'm the National Sales Training Manager for the Goodman Amana Daikin brands. Here we are just at about 10,000 feet just below the summit of Pikes Peak. And I'm joined here with Ben Lipscomb. He's with National Comfort Institute. Why are we doing this? We're out talking about the benefits of Daikin's true inverter heat pump and talking about the fact that it can be installed in just about any climate, any environment. Ben, we're going to talk a little bit about that today. We're going to talk about cold climate heat pumps. We're going to talk about airflow. We're going to talk about all the science that goes into this and how contractors are helping homeowners, save more money, be more comfortable, and really get systems that perform at ways that they've never performed before.
Sounds great. Can't wait to get into it.
So Ben, let's go a little bit into your background. Tell us a little bit about how you got into HVAC.
I kind of fell into it when I was a kid. I sort of knew I wanted to be a mechanical engineer and ended up in this high school program where they placed me in a lab, a university lab, and it happened to be an HVAC lab. And I didn't even know that HVAC was part of mechanical engineering at the time, but got placed in there and never came out, I guess.
Okay. So when we talk about heat pumps and their performance in different climates, I think, in the 1980s, there was a big push for heat pumps and electrification, but a lot of those systems ended up failing. What was some of the big reasons why they didn't work the way that they thought they were going to work at that time?
I think that the engineering just wasn't there to make them perform in colder climates, and they were kind of really designed to work in warmer climates. And then they got popular through gas becoming really expensive, and they got installed in places where they were never designed to be installed in the first place. And so you ended up with heat pumps in the Midwest and places like that where it got really cold and people expected them to heat their house and they just didn't work.
Well, right behind us right now we got snow-capped mountains here. How has heat pump technology changed today to be able to address some of those concerns?
There's a lot of different technologies that go into the heat pumps today. Big one, of course, is inverter compressors. So you can actually, build the heat pumps with larger coils and larger compressors and things like that. So they have the ability to work in colder climates. But then, when they have to work in the more moderate temperatures that we usually see, then they can ramp down and kind of match the load. So the inverter compressors and accumulators and things like that kind of help that refrigeration cycle work better is kind of the key there.
So we get a lot more capacity out of the units that we're seeing now. Can you explain a little bit, what was the cold climate heat pump challenge all about?
The cold climate heat pump challenge, as far as I know, I wasn't directly involved with it, of course, but I think it was Northeast Energy, NEEP initiative that, I think they basically just challenged the manufacturers to make heat pumps that would work down to, I think, 100% capacity at 5 degrees Fahrenheit outside. And manufacturers responded, and, basically what they are is they're oversized heat pumps that have inverter compressors that make them perform, like they should. Say it's rated at 3 tons, it's really built like a 4 ton, and then the inverter compressor makes it perform like a 3 ton, but can go ahead and ramp up when the temperatures get colder out.
Let's get down to those colder temperatures.
Yep.
So when we talk about heat pumps, obviously one of the things that's really important is sizing of equipment.
Yep.
And making sure. So what are some of kind of things from a mechanical engineer standpoint that you look at when you're sizing a heat pump in colder climates?
Obviously just starting with good solid load calculations is where you want to start. But then with heat pumps, you got to kind of really look into the difference between the heating and cooling loads and figure out a strategy, for do I want to select a system for the cooling load and provide some supplemental heating, or do I want to select for the heating load and accept, maybe some efficiency loss or loss in dehumidification on the cooling side? So there's some, pros and cons to that. And in colder climates, you're always sizing for the heating load. And, a lot of times the cooling loads, you might get some period of time when you need a lot of cooling during the year, but they're not, near what the heating load is. So you kind of just accept the loss in efficiency and the loss in dehumidification, especially in a climate like this that's really dry, and it doesn't really matter. But what's interesting to me about the cold climate heat pumps is that even in warmer climates, like say in the Southeast, like Georgia or Tennessee or something like that, it can be beneficial to select one of the cold climate heat pumps, because what that'll allow you to do is actually kind of balance out those heating and cooling capacities in the piece of equipment, and allow you to select for the cooling load and meet the heating load without having heat strips, or select for the heating load and not take a big hit on dehumidification performance.
So if I'm sizing for heating, though, one of the things I got to keep in mind, if the original home was designed for, let's say, a 2.5 or a 3-ton system, and now I'm sizing for heat and I need 4 tons in order to heat that system properly, now airflow becomes a challenge.
It does. Yep. And that's where, you really got to look what the ductwork is in the space that you're wanting to install this in, and make sure it's adequate. And if not, the best thing to do is just to go ahead and do some surgical repairs or replace some sections of duct to kind of remove some of those restrictions and allow you to get the airflow that you need.
Now, this is really where NCI shines, obviously, in airflow.
It is, yeah.
And so when we talk about airflow in systems, I mean, even systems today, they have a single speed air conditioner in there, and it was 3 tons and it was working fine, and now they're looking to move into a 3-ton inverter system. There's a lot of duct systems out there that do not have the capacity for that new system that's going in. Can you explain a little bit, why did it work with the single stage, and why are we having challenges when we go to the inverter technology and putting in the more efficient equipment?
Well, odds are it didn't really work with the single stage. A lot of times folks just think it worked, and they kind of got used to being uncomfortable in certain areas. But one of the things that I think happens is when you go to the inverter equipment, they also have variable speed ECM fan motors.
Right.
And so the older equipment had PSC fan motors, so those ducts would just throttle the air, and you wouldn't get very good performance or efficiency out of the unit. The air would be really cold coming out of the vents, and the system just kind of chugged along. With the newer equipment, that fan's going to go ahead and try to ramp up, as high as it can to provide the airflow that the system's calling for. And I think sometimes the people feel like it's not energy efficient because that fan is having to just chug along to, keep up with the demands of the equipment, when it's really the duct system isn't big enough for what the system's trying to push.
Well, and getting those efficiencies, if you're not moving the proper airflow across the coil,
Yep.
You're using an electronic expansion valve, you're not going to get the right temperatures across the coil. You're not going to get the dehumidification you're looking for, and so there's all kinds of things that kind of get thrown out of whack.
Yep, absolutely. Either the fan motor is going to be the blower motor is going to be having to work way too hard, and you're going to lose efficiency there, or at some point that reaches a limit, and then you're not going to get the airflow, and the refrigeration cycle's not going to work right. So.
Sure. So what are some of the easy things that NCI recommends to contractors that they should be doing on every single install that they do in order to ensure that they are getting proper airflow? And what are some of there may be some simple fixes maybe that contractors can do without having to redo a whole entire duct system to make the systems work better?
Yeah. I guess kind of our whole thing is that if you don't measure, you're guessing.
Right.
So we always start with measuring what's going on with the system. So measuring things like total external static pressure, measuring airflow in the existing system to see what kind of airflow you're getting out of the existing system before you put in a new unit. So once you kind of have that data, then you can start to see, okay, maybe I'm restricted on the supply side, or maybe I'm restricted on the return side. And that can allow you to like pinpoint what you need to fix or replace to be able to have a successful install with a newer system. A lot of times returns are undersized, and that can be really easy, you know, putting in a new return. A lot of times they're pretty short, so you can cut them in quick and just be ready to go. And that's all you needed.
Just allowing the system to breathe a little bit better.
Yep.
When contractors join NCI, what are some of the big things that they take away immediately and start to change, and how does that impact their business?
You know, I think one of the things that they really pick up on first is just measuring static pressure on every job. It allows them to spot issues, you know, before they would have even thought about them before, you know, after the homeowner's calling them back to the job for the third time and they're wondering what in the heck is going on. And, you know, after they take a few of our classes and put all their technicians through our classes and start to get all that data, now on every job that they go to, they can measure static pressure and be confident that, okay, we can put a new system in this and it's going to perform.
And then you actually certify contractors. What does that certification mean?
So it depends on the class. We have a bunch of different certifications, but basically the certification means that they came to the class, they took the exam, and they passed. And that's that's about all that the certification means. So, you know, we're not like insuring them or backing them up or anything like that. We're providing the education, and they're proven to us that they learned what they needed to know to get that certification.
But what does that mean to the homeowner?
So to the homeowners, you know, I think it's just gives them like a mark of additional quality that contractor is willing to take the time to train their employees, and that, you know, they're getting something better than like just one guy in a truck that, you know, is using old rules with them and things like that to replace the system. And a lot of homeowners have experienced, you know, that kind of contractor and they get frustrated, you know. So I think it's just a little mark of quality that they're willing to take the time to do the training and do the education for their techs.
One of the things that we've been talking about are the industry standard practices when it comes to install. And so I think it's super important that we talk about whether it's a single stage, air conditioning and furnace, or it's, an inverter driven heat pump. There's some standard practices that should always, be looked at as far as putting a system in, such as, like you said, checking the static pressure, making sure that the airflow is proper. Even with that single speed system, maybe, but to your point, it might chug along, but it's not delivering the efficiency that was promised. It's not delivering the same BTU capacity that was promised. It's not doing everything that it needs to do there. But then there's other things, such as, when you can, making sure you're pulling new control wiring, because the weakest point in any system is going to be the part that's going to fail. Or it's making sure that, you're redoing the plenums, redoing the return drops, making sure that you've got the sufficient airflow going through those systems when you're putting that in. What other kind of industry practices does NCI teach to contractors that they should be doing on every single install?
I think definitely things like properly charging the system. If you've got a longer line set than what the manufacturer allows, weighing in the proper amount of charge for that, and then checking everything out afterwards. If you ever have to evacuate a system, making sure you pull a good vacuum. If you ever have to do any brazing, making sure you're nitrogen purging, and kind of all of those things related to the refrigerant side. We go into that as well in our refrigerant side performance class. Other than that, a lot of what we teach is airflow and duct system related. And then a lot of what we teach as well is figuring out how to relate all those measurements and the testing that we teach them to do to the homeowner. So we teach kind of an educational sales process where we allow the homeowner to tell us what they think is wrong with their system, and and then we can help them validate, what they think might be wrong through measurement, and show them, this is why that's happening, and I can fix this, and this is exactly how I would fix it. Rather than just the old shotgun approach of, let's just put in a bigger unit, when in fact that might make it worse.
Right.
So,
what tools do you recommend that a contractor should use to do that?
I mean, definitely just the basics, like a digital manometer. You're gonna want one of those. Couple digital psychrometers can help with, checking temperature splits and things like that. Even checking temperatures at the supply registers and return grills to see what kind of losses you're getting through the system. So those are kind of like the basics that you would want to start with. And then a newer tool that I would recommend that most better contractors get is a TEC TrueFlow.
Okay.
So that's an airflow meter or airflow plate that just slides in place of the filter, and allows you to measure airflow through the equipment very accurately.
Okay.
And that's a great way to verify, what's going on with an existing system. And, once you put in the new system, you can just verify that the airflow you're getting is correct. So.
Well, Ben, I really appreciate you coming out here, being on the podcast.
My
we
pleasure.
couldn't ask for a better location to be.
Yeah, it's beautiful out here.
Do you have any last words of wisdom that you want to share with our guests?
Last words of wisdom, huh? I mean, I think that just taking the time to get the knowledge that you need, as new equipment comes out, as new tools come out, to stay engaged and present in your career, and it'll help out your business, it'll help out you, it'll help out your customers, and I think that's the way to go. So.
All right. Well, thank you so much for joining us. I really appreciate you coming out here.
My pleasure.
For all of you that are out there, if you like this episode, please go ahead, hit that like button. Also, make sure if you're listening on the podcast, make sure you're following us. If you're on YouTube, make sure that you're subscribing to it. But as we think about all of these things that we're talking about, I want you to really think about, where can I apply that true Daikin inverter heat pump experience? Where does it make sense to really tie that heat pump in, make sure that you're offering it to customers on a regular basis, giving them the choice, giving them the option to take advantage to that added comforts, to the energy efficiency savings that they have, and, really remembering that this is not the old heat pump technology. This is heat pump technology that has been proven globally and is helping customers in just about every single climate that is out there. Again, my name is Ben Middleton, and until next time.
It's actually a very safe refrigerant.
Daikin wants to be involved in the community.
Making another touch point to build my brand.
So the first question we ask everyone is,